Hi, it's Dr. Mamari again. I'm sure by this time you already know my name and you know why I'm doing this experiment. So, week 4 experiment is about unknown, group 3 unknown, qualitative analysis of group 3 unknown. Your known sample of group 3 had 5 ions. You had iron, you had manganese, zinc, chromium, and nickel. I hope that you have the observation clearly and in detail recorded in your lab book. Now, by watching me performing the experiment, I'm not going to say this is the presence of which ions. I try not to give away the answers because that's your job to find out which ions are present, which ones are not present. Then use your lab notebook. So if you had any questions, you can go back and watch the video from week 3. This is the week 4 experiment is for analysis or qualitative analysis of unknown. I'm going to follow the same procedure as the known sample. So basically the flow chart, I'm going to start with, instead of knowing what we have here, these are X, Y, and Z that I have for the first box, then I'm going to treat my sample like I have all of them, unless the opposite, or it's proven that we don't have it, or we are looking for the evidence that it shows for sure we have that ion. Not all of them is going to be present, of course. So sometimes they tell you like maximum how many you have. So if you know you have like 3, then you know when you find 3 for sure and you're confident about it, then you can even stop. But let's start with the procedure. I'm going to start with the procedure. I'm only reading the procedure to you. I'm not talking about evidence. What does it mean? Because those explanations were presented in your week 3. I'm sorry I'm repeating this. I just want to make sure that you say, okay, what is this? Well, you are responsible for that, to find out what is that. So what does it mean? Compared to the known sample, then you know what it means. Okay, we are looking for unknown, group 3 unknown. Let's see that unknown group 3 definitely is here. Okay. Just the unknown A. Group 3, 10 drops. Follow the procedure. I am going to add the 15 drops of sodium hydroxide, because that's the procedure is telling me to add the 15 drops of sodium hydroxide. 1, 2, 3, 4. And 5 drops of hot water. We'll have the hot water here. For you to see what happens after. This is just after adding sodium hydroxide. Okay? Adding sodium hydroxide and hot water. Make sure that my test tube is balanced. We're almost there. Stay balanced. And centrifuge. Okay, centrifuge to stop before I take the test tubes out or open it. The liquid portion separated. Is telling me to keep the liquid for part B and the solid for part C. So I'm going to separate it. So moving to part B now, we want to add the hydrogen peroxide to what is left to the solution from part A, adding hydrogen peroxide. I added hydrogen peroxide. Record your color. Just adding hydrogen peroxide. Added hydrogen peroxide. Then we are moving to part C. We are not done with the solution yet. We're just going to continue in the later steps. For part C, I'm adding HCl. I'm following the procedure to add HCl. To the solid that is left from part A, I'm adding HCl. Sorry. 3C1 HNO3, acidic, but HNO3. 15 drops of HNO3. And we want to make sure that we stir it with the clean stirring rod. It tells me to stir it with the clean stirring rod until is, and heat it up until is dissolved. So I add the HNO3, placing in hot water bath, and stirring until is dissolved. Wash it again. So make sure. I'm going to leave it there for 2 minutes to dissolve completely. So we are in part 3C, where it's asking me to add, it did ask me to add 15 drops of 6 molar HNO3 to the precipitate from 3A and heat the mixture in water bath for 2 minutes for it to dissolve. If I see black particles, I have to centrifuge it. If I don't see it, I can skip the centrifuge part. Just waiting for the 2 minutes. I don't really see the particles, but just to make sure, I'm going to centrifuge it. It's better to be safe. It's better to be safe than sorry. That's the same, right? So I'm still in part 3C1. I centrifuge to make sure if there is any black particles, it settles down. Don't see any settlement, so just to make sure. Because we don't need the precipitate, we just need the solution. There wasn't any, which is just to be safe. So we are now safe. Okay, it tells me to add the 15 milliliters of water. This is like before adding the water. There are 15 drops of water. I'm going to add water. And then divide in 3 separate test tubes. Just like the known sample that you saw for week 3, I'm taking 2 other test tubes. And I'm trying to divide what I have in this test tube into 3 test tubes. Just to make sure it's mixed well. Okay. There's some of it. Okay. I have 3 outputs now, 3 test tubes. I'm moving to part D, to the first test tube, adding KSCN following the procedure. Because if you were in the lab, you would do the same. You would do the same procedure you followed for the known sample, with the exception that you don't know which one is going to be positive, which one is going to be negative, and you have to wait for the result and just record your observation. So you're going to add KSCN. Okay. KSCN, we're adding 2 drops. After adding KSCN, this is the solution. Record your observation. So you can decide later if you have any iron or you don't have iron. Okay, record your observation. This is for part 3D after addition of KSCN. Now for part 3E, we are going to take the second aliquot, the second test tube, add the 6 molar HNO3, to separate if there is any iron or manganese in there. NH3, ammonium hydroxide. So we are I'm following the procedure, just adding the NH3 until the solution is basic. This is after adding NH3. Right? And just to help you decide, to take this is water. This is after adding NH3. I want to make sure it's basic. So I'm taking red litmus paper, 1 piece of red litmus paper. Add a drop. Take a drop, add to the red litmus paper. If the litmus paper turns blue color, that means is okay. It turned blue color, that means is basic. So I just go to the next step. This is still 3E. It tells me to centrifuge and decant. To the clear solution, we're adding more NH3 to see if it turns cloudy. Again, if it turns cloudy, I have to centrifuge. It did not turn cloudy, so it's telling me just keep the clear, discard the solid based on the procedure. Moving to 3F, adding H2DMG. Moving to the 3F and adding H2DMG. Adding H2DMG. Record the observation. This is for part 3F. And you are using your observation to decide presence or absence of ion for part 3F. 3G. We are going to take the third sample or the third aliquot of the solution that we had saved earlier. Going to add a couple drops of water following the procedure. 10 drops of water. 2 drops of HNO3. To make sure the solution is acidic. Okay. This is before adding the actual reagent. And then we add small portion of sodium bismutate, so NaBiO3. Okay. After adding the reagent, this is for part 3G. Record your observation. So record your observation in order to identify presence or absence of ion from part 3G. For part 3H, going to place the solution in hot water bath. So it says to make sure that H2O2 is decomposed and removed. I don't see any more bubbles. Because there's no more bubbles, means that H2O2 has been decomposed. I'm going to add barium chloride. I'm going to add barium chloride for the next step and look for evidence for the reaction. Okay, we're going to add barium chloride. This is part 3H2. Okay, this solution is cloudy. I'm going to centrifuge, separate the particles. So if the new precipitate forms, it would be easier for you to see it. I don't want you to get confused if it was there before or is the new one. It's not part of the procedure, but I'm making easier for you to see formation of new precipitate if it forms. I feel better. And it's more fair to you because if the precipitate forms, at least you know if it's new precipitate forming or if it's there from before. So we have a clear solution now. We are adding barium chloride. Wait for a couple minutes, just like for the known sample, and then compare with test tube water if we see any difference in transparency. Let me test it. Just for you to see. This is not confirmation, it's not part of the procedure, but I want you to see if it's more cloudy one or less cloudy, the difference. The procedure is asking me to centrifuge it and look for a formation of precipitate on the ball. Centrifuge this now and look for the result. Just make sure the mass is balanced on both sides. we are performing experiment, as I said, there are some downtime. And if you were in the lab, you had the same experience, you would have had the same experience, but since it's like group of you and you could ask questions, you could talk to each other, and it doesn't seem like you're waiting. But what I suggest you to do while there is like a downtime, what you could do, you can start thinking about your observation, recording what has happened today versus what you had from last class, and compare the unknown to the known sample. Okay, here is the evidence after adding the barium chloride. Record your observation because you need to identify based on the observation if you have ions present or absent. One more time. This is part 3, H2. Okay, part 3, H2. Okay. Next, 3I. We take this is the leftover of the 3H2. For 3I, we're going to add HCl until the solution is acidic. That's what it's asking to do. And we are going to make sure to test it with a new, clean, mix it well, and test it with the litmus paper. It's acidic. A blue litmus paper is supposed to change to pink color. So when I add the solution to the blue litmus paper, it's changing to pink color. It is acidic. Can now add the reagent, and if you get the precipitate that is a yellow color, we are looking for precipitate that is a yellow color or no precipitate. So I'm going to bring the reagent, the K4FeCN6. And you need to look at the solution for presence of precipitate or not. I mean, we can centrifuge it, but we're not looking at the color. We are looking at transparency. If the solution is transparent, that means there is no precipitate. And if it's not transparent, yes, there is a precipitate. So you can use the observation to decide. If we centrifuge it, it's just going to assures that there is a precipitate or not, which I'm going to centrifuge it. But from the transparency of the solution or not transparency of the solution, you can also look at it if there is a precipitate or not. This was for part 3J1. 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 Just have to add some water to the other part because I want to make sure that it's the same mass. I don't want my centrifuge to start dancing here. Check for evidence of presence or absence of ions. Okay. I'm just going to help you with one thing here. I see color. I don't see precipitate here. And that was for 3J2. And that was the last part for the unknown 3. Qualitative analysis of group 3 unknown. And I hope that based on the evidences you have, or your observation from week 3, you can identify your unknown. Okay. The letter used is letter A, just in case somewhere in the report is asking, what is your unknown? The letter for the unknown. And I'm going to stop recording, and thank you.